Today our topic is to learn about the combined functions. The topic is combined functions. Okay. Combined functions means like you know that when you are having a certain function, it can be explained by different type of ways, just like this. For example, if you get fx equals to, we'll get x plus 2. This is a simple function. So that way throughout the time, it satisfies this condition. It does not make change for any other figures. But the combined function means sometimes, so when you come up with a function, it might be behaving in different ways. It can be like this. You can say x plus 2 is, this is the way when x is less than or equals to 2. This is the way of its behavior. So other fact is they mention x squared for the situations x is greater than 2. Greater than 2, this is the behavior. That means you can sketch a graph like this. Look at this. So you can see up to 2. 1, 2. Up to 2, it's behave as this. That is what you mean by this. That means if I put 2 here, the value is 4. 1, 2, 3, 4. It's 4 here. It's the 2. That means 4 is already there. And just like this, it's traveling through, the intercept is 2. So it's a function like this. It goes like this way around. It's a behavior for over here 4. Then the other one is, if you start with y equals to x squared, for more than 2, it's like this, 3, 4, like those figures. It should be x, the function is x squared. Means after 2, it's not this function. It's not this. It satisfies this condition. That means if I put this one, at 2, it's turned up to 4. And at 3, it's turned up to 9. Like that, it goes like this way around. So that is what you mean by a combined function, because the function behaves in two or multiple ways in different ranges. You can say x and this is y. And then you can say fx also, just like this. You can put it. That's a way of, that is what you mean by the physical meaning of what we call that a combined function. We'll go for another function. We'll say gx is equals to like this. It can come across here like this way around. Can be like this. It can be x plus 2 for the range of x is less than or equals to 2. It can be 4 for the range of we'll get 2 to 3. Then it can be 4 minus x for the range of x is greater than 3. Right. Let's draw this graph. So initially, if I just plot this, it's just like this. Right. 1, 2, 3, 4, 5, so on it comes. X values and this is y values. So this is turned up to 1, 2, 3, 4. Just like this. For the first case, is for x equals to 2. 2 will allow this turn up to 4. Right, okay. Then after that, this is the first range. So here this value is included, therefore you have to put a dot over here. Right. Then the next part of it, I'll just make it link this way. I'll make a small change over here. I'll make this as 3. It's not a problem, 3. Right. Then if you're starting from 2, the value is, I will use a different color to explain that part of it. It's a red color. Here it's 3. 3, but in this point, it's not satisfied. 2 to 3, but it satisfies the condition of 3 at 3. It satisfies, so therefore it goes like this. I'll tell you the reason to draw like this. More than 3, the function is 4 minus x. At when you turn up to x equals to 3, it's turned up to how much? If your x equals to 3, it's turned up to 4 minus 3 is 1. So at 3, it's 1, but it's not belongs to this point. So you have to put a dot over here. and 4 minus x. So it's a graph like this. I draw it in a different color, then it will be much clear for you. Here it's not belongs to this one, like this. Then you may be thinking that what is the point of drawing this dot and this what you call colored dot and what do you call that the circle part of it. This dot indicates you that the value belongs to x equals to 2. But this color dot represent the value do not belongs to x equals to 2, but if it's slightly more than that, it starts to satisfy. But that's a condition where we should know about this function. So why do we have to mark like this, Pute? Because you know that for the functional behavior, for one x value, you cannot see two x answers for that. That's a fact we need to understand for this function. So you can say, if I just mark up this behavior from a different color, we need this requirement to be a function. If I just put it here, so you can say we need this behavior since for one x value we cannot obtain more than one y values if it is a function. If it is a function, that is a property. Under that property, you cannot say like this. Okay, we'll go ahead with another example and try to make it much clear. Right. Okay, we'll go ahead with this one. So like this, hx. It's given like this. This is x plus 2 for x is less than or equals to 2. The other one is x minus 1, x is greater than or equals to 2, right? So let's draw this graph. If you draw this graph, what you can understand is like this. At 2, the function is here, it's 4. So it's a graph like this, it travels to 2. The other one is x minus 1. If it is 2, 2 minus 1 is 1. And it's like this. X minus 1. Sorry. Yeah, x minus 1. So it goes like this way around. Minus 1 means it's like this way around. Then can this be happen in a under the conditions of a function? Now you can see at 2. At 2, there are 2 solutions. Why is that? Because you know that this belongs to x plus 2. Sorry, belongs to x equals to 2. This value also belongs to x equals to 2. Therefore, for x equals to 2, there are 2 solutions. So in this case, at 2, actually at 2 means at x equals to 2, there are 2 solutions. Therefore, hx is not a what? Is not a function. So that is a condition where we should know for one x value, you cannot obtain more than one answer. So I just highlight this point because at 2, you have 2 solutions. Therefore, it cannot happen. Right? I'll go ahead with another example as well. I'll show you this condition. Again, is we'll get mx. Mx is equals to, we'll get the same example. I'll explain it. X is less than or equals to 2 and x minus 1 is x is greater than 2, right? Oh, that's great. Okay. Now we can explain the situation. Yeah, sorry. This is equal is not there. I just right. Okay. Now when you draw this graph, look at this. at 2, according to this one, it's 4, but this value is not belongs to 2. It goes like this. And the other one is x minus 1 is 1. It goes like this. Now you can see this is not belongs to 2. Not belongs to x equals to 2. This value also what, Pute? Not belongs to x equals to 2. So in this case, what you can understand here, at x equals to 2, if I put x equals to 2, it does not explain by this equation or this equation. That is a fact we need to understand. So that x equals to 2, you cannot get a solution for x equals to 2 from any of these equation in the function. Therefore, the function does not satisfy any condition at x equals to 2. To be a function, what is the requirement? Whatever the value in the domain, there should be a solution. So you can say we cannot obtain an answer for x equals to 2 from mx function. Therefore, mx is not a function. That's a fact we need to understand from this example. That's a way of getting it. Okay, right. Okay, let's go a little bit further. Just like this, we'll get nx. It's equals to x plus 2 and x is less than or equals to 2 and x minus 1, that is x is greater than 2 prime. So for this situation, just like this, at x equals to 2, it's 4. Here it belongs to this point. Okay, so it's just like this. And the other one is, it's 1. So here it goes like this. Right. So here what you can see, Pate. Then you can see for all x values, there's a functional value. At x equals to 2, it's explained this belongs to 2. Belongs to x equals to 2. Not belongs to x equals to 2. Therefore, at x equals to 2, only one solution. So it's a function. So you can say nx is a function. But the reason, because you know that for all the conditions of a function, it's satisfied by this relationship. That is a fact where we need to understand from this theory. Okay, right. We'll go a little bit further. Right. Now let's go ahead with some situation just like this. We will get effects. This kind of function x squared for x is less than or equals to 2, and other one is x plus 4, x is greater than 2, right? Okay. Initially, we will draw the graph. Part A, draw fx. Yeah, that answer, I'll write it over here. If I sketch this, it's just like this. At, you know that it is x squared graph at 2. If I put 2 here, it's turned up to 4. Somewhere of it belongs to that point, and it's a graph like this. It's a graph like this. The other one is x plus, sorry, I just did a mistake over here. It should be not x plus x, should be x plus 1, suppose. So this is 4 and this is 3. This is 3 and it's a graph like this. This is the way of this is the shape of the graph. Right. Okay. Then part B. Part B, draw fx. Uh, right. Then when you work with that, initially they can ask a value like this, but they can ask you find F3. Now see whether 3 belongs to which range. You know that this function is belongs to x is less than or equals to 2. 3 is not in this range. So this is the function where it's 3. Now if you use the diagram itself, you can say 3. 3 is a value over here. It is explained by the second function. So what you can get here is that you can say this is 3 plus 1. It's equals to 4. C. If I need to get find F1. 1 is belongs to which range? So I'll just erase this bit of it. You see, already got the answer from that. Then F3, F1. Where is F1? F1 is somewhere here. So it belongs to the first function. Therefore, you can say F1. It's just like this. It's explained by the first function. The first function is x squared. It's turned up to 1 squared. It's turned up to 1. Just, sorry, strong color. 1 squared equals to 1, right? That's the second situation. So I'll just erase this bit. Then it's kind of messy if it's just. Right. Then part D. Part D is they want to find A such that. That's a way of asking this question, Pate. If A is equals to 9, right? Now that means a y value is given. We need to find the solution for this. Now look at this, how to get this. 9 is a value somewhere over here. I'll use the different color to represent it. It's a 9. So you can see, if I draw a line over here, one solution appear from here and another one solution appear from here. Now let's work out with this. Because you know that for 9 is satisfied by both the conditions. From the graph itself, you can get this answer. We will put it in the first function. The first function, x squared equals to 9. That means I'm using the first part of the function, this part of it. Right, okay. Then what you can say, x equals to plus or minus square root of 9. The first answer is for the x equals to plus 3 or x equals to minus 3. But you know that this function satisfy only the conditions x is less than 2. So you can say x is less than or equals to 2. Therefore, this solution is not exist. That means you can say x equals to 3. Obviously, from this function, even you can understand this 9. 9 equals to how much? It should come up, the diagram is kind of wrong. This is the first answer, 3. Right. Then the second function, we replace the second function as well. Sorry. It's wrong. I just made a mistake. This is not, minus 3 is there. Sorry. It's my mistake, sorry. X is less than 2, therefore plus 3 cannot exist. Sorry. The plus 3 is the one where we cannot exist. So answer is x equals to minus 3 is there. That is the answer for that. This is not there. Sorry. This is not come from this function. This is the function we are just concerning about. This is the answer. Minus 3 is there. So solution for this part is minus 3. Now the other part of the function. What is the other part of the function is x plus 1. So you can say next part of it is x plus 1 is equals to 9. Therefore, x equals to 8. That is the solution which is available here. So it's more than 2. This is the answer for what you obtain over here as x equals to 8. Then you can say the solutions are, what are the solutions? Solutions are x equals to minus 3 and x equals to 8. That's a way of getting a solution for this. That is the way of understanding this kind of situation. Right, okay. We should know how to do this kind of questions as well. We'll go ahead with the another question also and see whether how to do that kind of situation. It's like this. Okay, the first part A, sketch. Sketch GX, right? We'll sketch this graph with it. If you sketch this graph, you can say it is 4 minus x squared for 2. If you draw it starting from 2, it's just like this. Minus 2, and the other one is for x is greater than 2. That x plus 1. The second one is starting from, this is 4 actually. It's like this. So it's here and this is colored dot, right? That's a way of drawing this graph, right? Then part B, find G2, sorry, G3. G3 means it's satisfied by the second function. 3 plus 1, it's equals to 4. Okay, then if you want C, find G2. G2 is explained by which function? But it's from here. It is 4 minus 2 squared is equals to 0. It's not explaining by the second function, so you can't get it. You have to get it from the first function itself. That's a way of getting this, right? Okay. Then the next one is D. Find K such that GK equals to 5. Now you can see from the graphical approach, if you go ahead, 5 is a value over here. It does not satisfy by the first function. Let's see from the numerical aspect even whether this happens or not, right? We'll just do it. I'll put to the first function. 4 minus x squared is equals to 5. Then I'll bring this x squared to this side and 5 to other side is minus 1. So you can say x equals to square root of minus 1 not exist. So obviously you can say it does not explain by the second function. Or sometimes you might get a solution, but the answer not maybe fall into the given range. Then we put the second function. X plus 1 is equals to 5. Therefore, x is equals to 4. Yeah. The x plus 1 exists for more than x equals to 2. So this is this value is reasonable. So the solution is only this. So you can say solutions x equals to 4. That would be the answer for that. That's a way of doing this kind of a question, right?